In our last adventure into the realm of competitive programming, we witnessed the raw potential and the undeniable challenges of melding AI with code strategy. A promising journey met with an unexpected stumble against a seemingly simple adversary. But every developer knows true growth lies in iteration, in refining not just the code we write, but the very way we approach its crafting. Welcome back to Frankly Developing. I'm your host Frank, and today we're not just going to fix a bug. We're going to go on a journey to transform our code using AI as a guide and mentor. The art of AI-assisted code improvement is what I'm going to show you, how it helps us to refactor our code and improve the overall quality. Together we'll dissect the decisions behind each line of code, understanding the principles of clean coding, and witness firsthand the impact of AI in code in enhancing code quality. This isn't just about beating a game boss, it's about mastering the craft, setting new standards and pushing the boundaries of what our code can achieve. So whether you're here to sharpen your programming skills, curious about AI's role in code refactoring, or simply love a good coding challenge, you're in the right place. Join me as we redefine what it means to code with quality. We're going to continue from our previous video, which I will link to you up here, where we have used AI to already get code that does the input parsing all the data and providing us with the necessary amount of data. And then the action selection, which picks from these actions the one that should be the best. And we also had some scoring evaluation, which evaluated which of these actions is actually better than another. So let's ask the AI to suggest some refactorings to us. And if we do that, we get some really good suggestions. The first one is to separate game logic from the selection strategy of actions, which makes perfect sense, and I would like to do that. And then the second one is to improve this decision making using a strategy pattern, so bring in design patterns. Okay. The third one, however, says you should enhance the action simulation in a sense that is not really a refactoring. That would change the functionality, make different choices of actions after all. And the fourth one is okay, it's really good. Use enums and structs for directions and actions. So basically get rid of the primitive obsession we see a lot in this current code base. The fifth one is implementing more sophisticated action selection, which again, not really a refactoring, we change action selection. And the sixth one is to optimize data structures and algorithms for performance, which is totally not what we suffer from at the moment, that it's too slow or anything. So that is a really bad timing and a really bad idea. As you can see, when you do AI-assisted refactorings like this, you get the good and the bad. Some suggestions are really strong and really good, and I would definitely recommend them on my own. And others are really some I would not recommend. They're not even refactorings. If you look at this precisely, you change functionality, which by definition is no longer refactoring. Let's start with addressing this primitive obsession and introducing enums and structs. And well, I generally have a video about this already, and I'm linking to it to you here. But this time we're going to look at this based on the suggestion from the AI. And if you like this sort of video, please like the video as well and subscribe to the channel to get more of this content. So let's take a look at what the AI generated us in order to get rid of this primitive obsession and introduce enums and structs. So first off, it introduces this enum here for the direction, pretty straightforward so far. Then the struct for the action has like an action type, which is still a string. So there's just these two things, but it is a string. There's the unit index, there's the move and the build direction now using the enum as a constructor, and the toString is overwritten, which the question is if you would still do this as a struct, for example, in the new C# version, you'd probably just use a record, which makes all of that code a little bit easier. And here's the extension to convert a direction enum to a coordinate, like it used to be, which is also pretty straightforward. Just a lot of code that we already have written there and available. And the input parsing basically remained the same, and then it kind of changed things a lot. So the choose action, it's still using the same input signature, but as you can see, the output was changed. We could have written the code, an automatic type detection that would automatically fix this. And then there's something here about this not being null checked, and in general, that's a valid thing. As we know, again, from this competitive programming environment, you're guaranteed to be given some actions, so this will usually not fail. And so this check is kind of strange here, and we can just basically reduce this whole thing. There is no need for a fallback action, really. You can see one of these typical comments being generated by ICE, which is just a crappy piece of comment. Because it's like, yeah, it's returning the first parsed action. Like normally you would just inline this variable, and then these are action structs for whatever reason, badly named. So well, call them the actual actions because they're parsed actions. And now choose the first action that is parsed for simplicity. Return the first parsed action, and action struct first is basically the very same thing. So none of these comments is really adding anything of value at all. Here you can see it's also now my mistake on renaming these, so maybe the action called parsed action. So get rid of that one. There's a few minor things that the IDE can help us on top of an AI, which doesn't have these features built in. So simplifying code like this is a nice combination of using AI and the IDE and your brains, obviously. And I can also see like unused parameters still, but we're eventually going to use them, so let's leave them for now. And this parse action here, as you can see, it's doing a straightforward split on these spaces. Picks the action type as the first one, parses the unit index to an integer, and the other two options to an enum, which matches our basic input. Actually seeing this, we notice it's no longer in use. Like, how does it choose an action? Well, it parses the actions and picks the first one. But wait, we wanted to pick one based on the scoring. So now the AI degenerates our code base again. Like it has access to everything we have here, but still it messes up big things sometimes like this. That is why you still have to do a lot of checking and double checking. So something got really messed up here. So maybe we can convince the AI to fix these things for us again. So I told the AI to fix these problems very precisely. That is actually working. So on the first try, what came back, it worked again. And we could play the game again. And we would still lose. Which is kind of good because we just wanted to do a refactoring, so it shouldn't get a different functionality and work better in any sense, right? But what are the lessons that we learn from this? Like if you use AI for this, it's generating a lot of code, and it's quite a lot of code that is just too much. Like this whole struct thing, instead of a one-line record, is just 20 lines too many. There's these comments we've seen that are just not adding any value, just loading things up. And so the quality isn't really that good. But on the plus side, once you are aware of these things and you check what's coming out as output, you can iterate on this and improve it, and then get the desired result that we want. Thank you very much for watching, and I hope you had fun. Also, have fun developing.